Hey, happy Wednesday. Sorry I'm not there with you, but we need to get through at least 3 problems in this packet, hopefully all 4. So let's read through the first one. A manufacturer of ski clothing makes ski pants and ski jackets. The profit on a pair of ski pants is $2 and on a jacket is $1.50. Both pants and jackets require the work of sewing operators and cutters. There is 60 minutes of sewing operator time and 48 minutes of cutter time available. It takes 8 minutes to sew 1 pair of ski pants and 4 minutes to sew 1 jacket. Cutters take 4 minutes on pants and 8 minutes on a jacket. Find the maximum profit and the amount of pants and jackets to maximize the profit. The idea here is that we'll come up with some inequalities, graph them, shade them, and then take the corners and plug them into an objective function that we'll come up with as well. Since we want to maximize profit, we're only interested in the maximum. They said let X equal ski pants. X is the number of ski pants we need to make. And they said let Y be the ski jackets. Since there cannot be negative pants or jackets, write 2 inequalities that represent that situation. Well, if X can't be negative, then X is greater than or equal to 0, and the same thing for Y. Y is greater than or equal to 0. And those are going to be very common for a lot of the problems we do. Part B, express the cutter's time to make the pants and jackets as an inequality. Okay, so we need to look at how long it takes to cut a pair of ski pants. How long does it take to cut a pair of ski pants? 4 minutes. And then we're going to add on to that how long it takes to cut a ski jacket. And that is 8 minutes. And then we have a maximum cutting time available of 48 minutes. Every pair of pants needs 4 minutes of cutting time. Every jacket needs 8 minutes of cutting time. And we have less than or equal to 48 minutes total to use for cutting. All right, we're going to do the same thing for sewing. Let's see, how long does it take to sew a pair of pants? 8 minutes to sew a pair of pants, 4 minutes to sew a jacket, and we have 60 minutes of sewing time available. Okay. Part D. We're going to write an equation for profit. And for me, this is always the easiest. A lot of the times I start with my profit or my objective function. All right, how much do we make when we sell a pair of pants? We make $2. And then we make $1.50 on a jacket. Okay. So we need to graph these 4 lines, shade it, find the corners, and then plug the corners in a table into this function. I think I'll go ahead and get Y by itself for these 2. So we'll subtract 4x from both sides. And then we will divide by 8. Negative 4 over 8 cleans up to be negative 1 over 2. And 48 over 8 cleans up to be 6. Okay, so why don't you go ahead and try and get Y by itself for the other equation, and then we'll go over and graph it. Alright, since we're only going to be dealing with positives, I can put the origin right here, and we'll let positive x go that way and positive x go that way. One thing I messed up on the other board, I ended up having an equals at the end of it. It should still be less than, and hopefully you have a less than for this one. Oh yeah, when you get Y by itself, I think this one is negative 2x plus 15. Alright, first equation is a vertical line on 0. Second equation is a horizontal line on 0. Third equation, got to start at 6. 1, 2, 3, 4, 5, 6. And then we're going to go down 1, right 2. Notice all of these are solid lines. And then for our last one, we need to get up to 15. 7, 8, 9, 10, 11, 12, 13, 14, 15. And we're going to go down 2 over 1. Because you can put negative 2 over 1. Okay. Last solid line. Okay. Let's see. If we think it's this section, we need to be less than our third line, and we need to be less than our fourth line. So, yep. I like it. Now we just need to plug the 4 corners into a table, into our profit equation. So we have 0, 0. We have 0, 6. We have, ooh, that spot's a little nasty. 1, 2, 3, 4, 5, 6, 7.5, 0, and then 6, 3, I think, is that last one. So we are plugging these in to 2x plus 1.5y. 2x plus 1.5y. So we have 2 times 0 plus 1.5 times 0. We have 2 times 0 plus 1.5 times 6. Let's see, 2 times 7.5 plus 1.5 times 0. Okay, and then we have 2 times 6 plus 1.5 times 3. 12, and that would be 4.5, so I think 16.5. Now I hope you're checking all of this math because it's actually late at night on a Saturday right now for me. So if y'all agree on a different number, then I'm sure it's right. But I'm coming up with a maximum profit of $16.50. Obviously this is not real life or else that business would be bankrupt. But what they should do to maximize their profit is make 6 pants and 3 jackets. That's why yesterday I was always saying the max is this at this point. This point tells you how much you should produce of whatever X and Y represented. In this case, it's pants and jackets. Okay, so I want you to pause this video, read through the next page, see if you can set up the inequalities, see if you can graph them, see if you can plug the corners in, okay, because I'm going to have a lot of that already done the next time you see me. Okay, so I let X be the number of Topaz cars we're going to make and Y the number of Mustang. If you have those flip-flopped, it's okay. You're going to end up with the same answer in the end, but our lines are going to look a little different and all of our corners are going to be reversed. For instance, if I had a corner at 2, 5, you would have a corner at 5, 2. But if everything else was set up correctly, we would still get the same answer. Alright, once again, they cannot be negative. Here we're going to make less than or equal to 1,200 cars total. So that's all of your Topaz and all of your Mustang, less than or equal to 1,200. Getting Y by itself, you just got to subtract the X over. So it's negative X plus 1,200. Going to make less than or equal to 600 Topaz cars. Going to make less than or equal to 800 Mustangs. So those are individual inequalities. And then hopefully you got the profit. 500 for every Topaz, 800 for every Mustang. If you had trouble with this, it's okay. This is only the second one you've done. As we do more of them, it'll get easier and easier. If you want to go ahead and pause it, do that now. See if you can graph them. On this graph, go by 100ths. Okay. Alright, so remember, we're just getting started and each problem has its own new twist, so it's okay if you weren't able to get all of these. But we can't plant negative acres of potatoes, so we've got x is greater than 0. Same for corn, y is greater than or equal to 0. We have $3,000 to spend on the cost of seeding, I think. It costs $20 an acre for potatoes, $60 an acre for corn, and we've got that max of $3,000. The one that might have been hard to come up with was the total number of acres. And we'll see this idea pop up again, so hopefully next time you get it, if you didn't this time. Acres of potatoes plus acres of corn cannot exceed 70 acres. Both of these, when you get y by itself, I think looks like that. And then I bet you got the profit equation, 150x plus 50y. So go ahead and pause it, graph it. This time let's go by 5s on the graph. So see if you can wrap it up. Did you get a graph that looked like this? If not, stop it here, look at it, see what you did wrong. And if you did, make sure you went ahead and finished up that table, because I'm about to put it up. Hopefully you came up with 70 acres of potatoes for a max profit of $10,500. Alright, so if there's still class time left, go ahead and read through the very last example. Let's make sure we all set up x and y the same way. So let's let x be premium and y be ordinary. But if there's not enough time, then just go ahead and stop it, come back to this video tomorrow to get this last problem done. Alright, so once again, neither of them can be in the negatives, but this time we also have a max amount that we can make of premium. The max is 4,000. We have a minimum amount of cases we can produce, so that's kind of like last problem with the acreage. X plus y was going to be less than or equal to 70. This time x plus y is going to be greater than 5,000. We're going to produce at least 5,000 cases. And then machining time, 18x plus 12y is going to be less than or equal to 72,000. Make sure you convert that into minutes, since these two numbers were in minutes. Get y by itself, coming up with those. Profit, 4x plus 3y. I really hope you're getting solid at making the profit equation. So, pause the video, graph the lines, see if you shade correctly. Be careful on the shading. Alright, a little different. A lot of the times it is the shape with the most sides, but here we graphed 5 lines, and the shaded shape is actually a triangle. Okay, we had to be greater than the equation that had a y-intercept of 5,000, and we had to be less than the equation that had a y-intercept of 6,000. So, if you haven't already, plug those 3 corners into a table to find the maximum profit. Maximum profit was $18,000. So we actually need to produce no premium paper and just make 6,000 cases of ordinary paper. So if there's anything that doesn't make sense, hopefully y'all have paused and gone back to see how things were worked out. Hopefully you've talked with each other about how to do things. Okay? And just in case you're curious, it is Saturday night right now, and no, my daughter has not been born yet, but if I'm not there with you, obviously she has been by Wednesday. Alright, hope to see you soon.